it lets you type stuff in right here. And once you're at the terminal, you're going to type in this right here, pip to what is this, a minus signs and version. So pip minus version. And you guys can see that for me, it says it's pip 20.2.3. It might be a different version for you guys, and that's totally fine. But make sure it tells you that what the version is. And once you guys finish that, let me know so we can move on. If you guys are still having trouble, you can always ask. You can always ask questions, and then we can try helping you out. All right, I believe that means that pip is not installed for you guys, unfortunately. Hmm. All right, give me a second so we can figure out what to do then, because you guys might need to download pip. so since you guys don't have pip installed, we're gonna try downloading it together. So to download it, I'm gonna give you guys this link. So I sent it in the general chat. And then let's go to the installation. All right, so let's try this command right here. So let me send that in the chat for everyone again. So this is the first command you can try. And if that doesn't work, I'll send you a different one. And you put these commands inside this terminal that you guys created. The same place where you guys tried to check for the pip version. So let me know what happens when you guys try that command, and then we'll see what to do after that. All right, so it looks like there's another error. Let's see how to fix this one. Do you guys know what version of Python you have installed? There should be a command. Let me find it really quickly. All right, can you guys try this command? Oh, Python 3? Python 3. Can you try this? Oh, Python 3.7.1? That's weird. Because it says if you have Python version 3.4 or later, pip should already be included. Alright. Give me a second while I try to find some kind of solution.
Okay, then for now, we can do some of the solo learn together. So I'll just we can do some of that together while we try to figure the other parts out. Okay, so some of you guys may have finished it already, but for those of you guys who didn't, you can either send your questions or we can just go over it together. Okay, I'll just start here. So it says the text in a print statement should be enclosed in. And when we put text in a print statement, that means usually it's a string, so we put it in quotes. And then, yeah, we put the print statement, whatever we put inside the print statement, we put it around the parentheses. So remember to open a parentheses and close it, because otherwise the print statement won't work. So like this, just remember to put your parentheses. Since I think many of you guys did this, I'll just go over it pretty quickly. And when you want multiple messages in your code, you can put multiple print statements and it will each put in a new line. So, we want this to be the order. So we'll just make sure we want "We are the champions, my friends" first, and we'll keep fighting till the end, and then "We are the champions," because after every one, there's going to be a, it's going to go to the next line. And which of the following options is the correct way to output "I've completed my first lesson" is going to be this one, because you need to write print to print it out, and you need to make sure you open the parentheses and you have quotation marks and on both sides, and then close the parentheses. So some of these, this one doesn't have quotation marks. This one didn't put quotation marks in the end, which is why it doesn't work. And this one, it didn't say print. I signed in. Here, sorry. Okay, it didn't save, so I'll just go through this again really quickly. Yeah, so when you finish it, it says lesson completed, and you get a reward. Why is it not letting? Interesting. I don't know why this is not saving. One second. Let me try to sign in again. Okay. So the next one, simple operations. So we can do operations like calculations in print statements. Like this, we know that 1 plus 2 plus 3, it will be 6, because it'll just add it like the same as math. And And multiplication is done with the asterisk symbol. So if we want to output the results of multiplying 42 by 30 or by 3, make sure to write print and use the asterisk. Okay, and division is done using a slash. So remember, if we do a single slash, then it will just be a float, no matter what values it should output. So this one, we do print. This is syntax again. Print Python is fun. And like in math, we can use parentheses. So that means that we do the parentheses first. So we'll do 4 plus 8 before we divide it by 2. So if we do 4 plus 8, it will be 12. And then if we do 12 divided by 2 with just one division sign, then it will become a float. So it will be this. And you can use the minus sign in front of a number to make it negative in Python. So if we do this, it will be -5 minus 1. Since it's in the parentheses, we'll do that first. So it'll be -6 and then times 3, which will be -18. Okay. So we can perform operations with really big numbers in Python. So this would work because in Java and some other languages, you might know that there's sometimes a limit that you can't pass over. So here, we want to make a print statement of the result of adding 42 to 29 and then multiplying that by 99. So first we need to put print to print it out, and we want to add 42 to 29. So we want to do that first and then multiply that by 99. So we can check it and that'll be correct as well. Okay. So there are problems like this within this solo learn. So it's kind of like a little program. So this one says that you need to calculate the points earned by a soccer team. The team won 18 games and ended 7 games as a draw, which means they tied. And a win brings 3 points while a draw only brings 1. So you want to create a program to calculate the output and output the total points earned by the team. So we can print first we know that they won 18 games. So we can do 18 times, oops. And then a win is 3 points. And then we can add that with the points that they'll get for a draw. So it'll just be 7 because 7 times 1, because a draw brings 1 point. And we can print that. And if we run it, that will be correct. Yeah, so make sure after each time, make sure you're logged in correctly so that your progress will be saved. This one, we can see that if we do 8 divided by 4, we do that first, so it will become a float. So 8 divided by 4 will be 2.0, and we do 2.0 divided by 2, which will be a float again because it has only one division sign. So 2.0 divided by 2 will be 1.0. so we're done with this lesson. And we can do data types. So, okay, so we learned data types like string, and int and float. So we can see, select the options that represent a string. So we know that strings either have double or single quotation marks. So these two will be correct. And integers are whole numbers, like this, so without a decimal place. So if we want to output 100, we do print and then 100. You can add, subtract, or multiply integers, which gives another integer as a result. So if you want 8 as the result, you can do 3 minus 1 times 4, because if you do 3 minus 1, that's going to be first because it's in parentheses. It'll be 2. And if you do 2 times 4, it'll be 8. And then next we have floats. Floats are decimals. And if you divide two numbers, even if they were integers, and you only use one division sign, it's going to be a float. And you can see which of the following is a float. It's only going to be this one, because even though this looks like decimal numbers, it's in double quotes, so that means it's actually a string. And just like integers, you can do math with the floats. So like this one, you can just add them all together. 1 plus 2 will be 3. 3 plus 3 will be 6. 6 plus 4 will be 10. It will be 10.0, and then 10.0 plus 5 will be 15.0. So since it has a float here, the answer is going to be a float. Even if there's like other integers here, since there's one float being added, the answer is going to be a float. So I'm sure you guys have should know by now the data types. Integers are whole numbers. Floats are numbers with a decimal point, and strings are text in single or double quotes. So here we can see that a float would be 89.7 since it's a decimal number. 42 would be an integer, and hello would be a string. Okay, so actually for now, we'll go ahead and you guys can see that we can do it like this. So since we already learned all of these should be like a lot of review. So make sure that you guys finish this by today and send their certificates. And we'll go ahead and Andy can teach. One second. Okay, here we go. Okay, yeah, Andy can go ahead and start. So instead of the pip, we'll be doing the pandas, since we can't install it right now.
Yeah, let me just open that up real quick. I'm just gonna share my whole screen. Alright. Can you guys see Jupyter? Can someone let me know?
We can see it.
Okay. All right. Yeah. So this is Pandas. So basically, I guess I'll introduce it. So Pandas is a Python library, like Hemisu was talking about. Libraries in Python, they allow you to just use more stuff than what Python normally gives you. So what the Pandas library allows us to do is it is used to analyze data, which is used a lot for machine learning, data science, it's just very important. So I guess we'll get started. So we'll go to the introduction. So I kind of already touched on this, but Pandas is used for analyzing, cleaning, exploring, and manipulating data. And just for a fun fact, the name Pandas has a reference to panel data and Python data analysis. So people use Pandas all the time in the real world, and it's very useful for cleaning data sets and making them readable. Because a lot of times you have data, but it's not easy to use. So here's just some examples of what Pandas can do. Let's say you have a big data set, like an Excel sheet. You want to find what's the average value, is there a maximum, is there a minimum? Do 2 or more columns have something in common, correlation? And if you want to go to the source code, they have a GitHub. So I'm going to open up Jupyter. Hopefully Jupyter works for you guys. And I was told that you guys do have pip on Jupyter, so if you want to test that, you can type exclamation mark. That's how you run terminal commands in Jupyter. You can say pip version and then run that. So if it says something like this, that means that you do have pip in your Jupyter. If not, then that is an issue. And how do you run code in Jupyter? If you don't know, you can press that or shift return, shift enter. So if anyone has any issues with pip, you can throw it in general. If not, I'm assuming that everyone's fine. Okay, so now we're gonna download Pandas using pip. So we can do that by using an exclamation mark and then pip install Pandas. Right, and then when we run that, I already have Pandas installed on my machine, but yeah, it should go ahead and download. And yeah, if you have any questions, you can ask them in the class 2 and 3. Okay, so I'll give you guys a few seconds for that. Okay. Moving on. Hopefully we're all good. So some more about Pandas. This was just how we installed it. This is what we just did. You don't have to worry about this part if we're in Jupyter. And then all the libraries in Python that we download using pip, you have to import them when you run code. So this was just installing it, and then now we're actually going to import it. So you can just type import pandas. Yeah, import pandas. You run it. Nothing happens because there's no output, but now we can use the pandas library. Okay. All right, so now we have pandas imported and ready to use. Here's a quick example. Just going to copy paste this. I'll explain what all this code is in a second, but let me just paste it in here. And I'll run it real quick. Give you guys a few seconds to do that. So I'll explain what this is. So we didn't need the second import pandas. Oh yeah. Okay. Should I just put it in like general? Is that fine? I'm not really sure how I should do that. Yeah, anyways. So first line, import pandas. We already did that. So that was just importing the library. And then second line, we're creating a object called myDataset. So this will be a data set, and then we have two columns. The first one is called cars, and then the second one is called passings. And then each column we have our data, which is the first column has BMW, Volvo, and Ford. And notice these are all strings. And then second column is the numbers 3, 7, and 2. These are all integers. And then make sure you have these curly brackets for your entire data set. And then we use these colons to separate the column name from the column data. And then we separate each column using commas. Right. And then now what this does is we're turning this data set or this dictionary. I don't know if we learned dictionaries, but that's what it is. We're turning this dictionary from a dictionary into a Pandas data frame. So the difference between a dictionary and a Pandas data frame, as you can see when we run it, it sets it up in this format where we have the number of rows, number of columns, the column names. So yeah, that's the most basic Pandas data frame for you guys. And then the way we make it, obviously, you say pandas.dataframe, and then you put your dictionary in it. Okay, so this is another thing that is often used by many professionals, I guess, or not even professionals, people that just use pandas. Sometimes it takes too long to type out all 6 letters in pandas. So if you say import pandas as PD, right, then every time instead of writing out PANDAS, you can just write PD. And that still works, as you see. So, yeah. And then moving on, this was just the same thing as before, and it's just showing you that it works. Okay. So now we can check our pandas version because a lot of libraries in Python often get updated. So just to make sure what version you're on, you can say print pd.version. And we know that we're using pandas 1.4.2. So yeah, moving on. So we're going to be talking about series. So what is a Panda series? It's basically when we had our columns, right? 3, 7, and 2, that's a column to us, but we call it a series. And all it is a one-dimensional array or a list holding data of any type. So this example is in integers, but you can have strings, floats, whatever. So here's an example. We have an array called A, right? And then we have, and this is an array. And then we want to turn this into a series. So we can say my series equals pd.series A, right? So we're turning A from a normal array into a series. You can print my series. There we go. So we have our row numbers here, and then here's our data, and it tells us what type it is. So in 64, that means it's integers. If I change this to a float, then they're all float 64, right? Just one last example, you can have them be strings, right? And yeah, strings are objects, yeah. Yeah, we'll cover that later. So next, we're talking about labels. So labels are, well, if you don't specify a label, just on its own, it's given index numbers. So I'll show what that is soon. So let's say I want to do print my series 0. It'll give us the first thing, right? Because this is at index 0, or the label is 0. If I do 1, then it'll print B, right? So that's the labels. And if you don't want to just use numbers, you can create your own labels. And we do that with the index argument. So here's the code right here. Let me just copy paste this. So we're creating a Panda series, right? And then it's called myvar. And then we're using the same A as before, which is 8. Here, let me change this. Actually, no, it's fine. So A is A, B, and C. We know that already. And we're now turning A into a Panda series, and we're having the indexes called X, Y, and Z. And then we're naming it myvar. So if we run that, you'll see instead of X, Y, or instead of 0, 0, 1, and 2 as the labels here, we have X, Y, and Z. All right, so let's say I want to change this to label 1, label 2, and label 3. When we run it, you'll see we have the labels. And then now we can freely use these labels if we wanted to print myvar label 1. Give us A. Right? So, yeah, I know it's moving kind of fast, but we went, just a quick recap. So we have Pandas data frames, which is this big thing right here, 2D, many dimensional. And then each one of these columns we see as columns is called a series. And series are one-dimensional. Okay. And then each item in the series has their own label. And by default, these labels are numbers starting at 0. But you can make your own labels by, when you call the series function, you give it the list first, what you want to turn into a series, a comma, and then you say index equals to. And then you can put a list of what you want your labels to be. All right, so moving on from that, and this is what we just did. You can use your labels after you make them to return the values of the item given the label. So just like we did before, we were using lists to make series, right? We had A equals a list or an array, and then we turned it to a series. You can also use a dictionary to turn into series. And what that does is it makes it so it already has labels. So you don't have to do this and create the labels, right? So this is our dictionary right here. And our key value pairs, our key is day 1, day 2, day 3, and the value is this number, or the number of calories we ate for that day. And if we turn that into a Panda series using the series function and we print it, you'll see it automatically gives us the labels that we had in our dictionary, and we don't need to specify that on its own. So that's pretty useful. All right, and then this is just an example of how we can only have some of a dictionary. Let's say we had this thing again, right? But we only want to do the first 2 days, right? We don't want to have all 3. So the way we do that, I'm just going to copy paste this. So now, same thing as before, use a series function. You put in the dictionary you want to use, but now index equals, you want to specify which indexes you want to use, or indices. So now it doesn't include day 3 because we did not specify day 3 as one of our indices. Right? Just to give another example, let's say I only wanted day 3, right? Then it only gives us day 3. And then now we're going to go back to data frames. So if you remember, data frames are basically series that are multidimensional. So in Python, you can have 2D, 3D lists, arrays, and that's basically what a data frame is. So let's say, shoot, sorry. Here, I'll just create this real quick. So our data, right, let's say this was a 2D array, or 2D, yeah, we have a list, or sorry, we have a dictionary, and each item in the dictionary is a list. So our first key could be calories, right? And this was just the same as before. What was it? 420, 380, 390. And then we also have duration. All right, so this is our 2D dictionary. And then if we want to turn that into a Pandas data frame, we can say df equals pd dot data frame. And just cast in your data. And then if we print df, you'll see we get this nice little table for us. And each column is what we have in this dictionary. And then each series, right? Each series in the column is this list right here. So, yeah. And you'll notice that the indexes or the labels are by default 0, 1, and 2, just like they were before. And yeah, here we'll have a quick exercise. So let's say you had a list called my list and you wanted to change that into a Pandas series. What would you write here? What function? I don't know if you're supposed to like put it in the chat or something. Oh, sorry, did you want me to send the screen? Okay. Yeah, so just let me know if you guys, I'm just gonna go on after this, but the correct answer is series. And if you submit your answer, you'll say correct, right? All right. Moving on. So we're going to be talking about data frames a little more. So like we said before, Pandas data frames are just two-dimensional data structures or arrays and a table with rows and columns. So we already did this, is what we did right here. This most recent one. I could put this in the chat if you need, I don't know. But yeah, So we have our 2D array right here, and this is not a Pandas data frame yet, but we use a data frame function to turn our data into a Pandas data frame. Okay. And then next one, we can use the loc function, right? So this is a new function, and it's short for locate. So basically what this does is it helps us find a specific row using an index. So let's say I print df.loc 0. Right, and then I run it. It gives us this first series, or sorry, this first row right here. And if I do loc1, then it will give us the second one right here. Right. 380, 40, and it gives us the labels also, calories and duration. So just one last example, if I do loc2, it gives us the last row. All right. And then we can do multiple rows also. Let's say I wanted the first two, then that would be rows 0 and 1. If I run this, oh, yeah, sorry. You have to put 2 brackets for these. There, it gives us 0 and 1. All right, so just something to note, we're using square brackets when we use the loc function, not the normal parentheses. All right, moving on. So before, you notice that the names of our indices were just these numbers. Let's say I wanted to change them, and the way we do that is we use the index function again. So let me just copy paste this again. So we have our data right here, and we're turning it into data frame, right? So we do, I'm just naming it df, short for data frame, and we do the function pd.data frame. Make sure your D is capitalized, F is capitalized. And then what we want to put as our parameters, we have the data we want to use. This case is just called data. And then we want to give it indices. We say index equals, and we have a list. So here we had 3 items. I'm just going to call them day 1, day 2, and day 3. Right, and then square brackets for lists, arrays. And then we close this thing off with the parentheses. And if we print df, you'll see we have indices now that we specified instead of the numbers, right? So obviously this is just a small example, but you can have like tons of items in the data. Yeah, and also, yeah, I'll give you guys a few minutes to write down this code and practice it for yourselves. Okay, unless anyone still needs time, I'm gonna move on. If you want me to slow down, if you have questions, you can throw in like the class stuff. Alright, so that was how we made indices or index names for our data frame. And then once again, we can use the loc, short for locate function, to find specific indices. So let's say I print ef.loc2, yeah, it would be day 2 because we renamed it, right? Day 2. Then what it would do, it would just print the row day 2. So same thing as before when we did the loc function, right? But instead of using the numbers, we changed the index names to day 1 to day 2, day 3. Let's say I wanted day 1 and day 2. Then we just do both of these, run it, and make sure you remember that you want 2 square brackets when you're doing multiple things, because it only takes in one item as an argument, and this itself is a list, if that makes sense. So you have a list of or an array of the indices you want, and then you put that as the argument instead of just one item. Okay. Yeah, I'll give you guys a second to do that. Alright, moving on. So we learned the loc function. Now we're going to learn how we can load files. Okay. Let's say we don't have like a CSV file to do this. Yeah. But yeah, I don't have a CSV file to use as an example right now. But if you did have a file, CSV is short for comma separated files, like many Excel files or something. Or actually, let's say I went in Google Sheets. Alright, so this is just basically yeah, so let's say I had like 1, 2, 3 as a data set. Yeah. Or, alright, I'm going to try to send this into the chat so you can do it, but first, let's say I have labels first, second, and third. And then 1, 2, 3, 4, 5, 6. So this is just a data set, right? It's not Python or anything. If you guys have used Excel, this is similar to Excel. I don't have Excel, unfortunately. But all it is just some labels. You have a data set, right? I'm going to call it my data. And if I download this as a CSV file or comma separated values file, right? That's what it was talking about, CSV files. And a lot of times when you're working with big data, you'll find that they're formatted in a CSV file. And that's just some info. That's what CSV stands for. So let's say I download this as a CSV file. It'll be called my data sheet1.csv. And then you can hopefully put this in Jupyter. Right, so if I open this up, this is what the CSV file looks like in Jupyter. It's called mydata-sheet1.csv. I don't know if I could send this in Discord, but if you guys open up a Google Sheets, you can make your own data set real quick, or if you have Excel, you can do that too. And all you have to do is go to File, Download, and press CSV, and it should download on your computer. All right. So I'll give you a few seconds to do that. And once you do that, you can just, if your computer has it, you can just straight drag it and drop it into your Jupyter notebook. Otherwise, you can press this plus, or not, don't that, press that. I'm not sure. If you're more familiar with Jupyter than me, you can add the file to your notebook. But yeah, I'll give you guys a few seconds to do that. Alright, you can upload files from your computer using this button up here. And so once you have your CSV file loaded into your Jupyter notebook, what you have to do is, instead of data, mine is called mydata-sheet1.csv. And you'll see now it takes our CSV file and it turns it into a Pandas data frame. Right, so if we look back at this, we have first, second, and third as our column names. We have them right here. And then they gave us index numbers 0 and 1, and then this right here is our data. Right. So yeah, that's the read CSV function. I'll give you guys a few seconds to work on that. Okay, so hopefully you guys were all able to do that. If you have any questions, once again, please put it in class 1, class 2, or class 3, and then the teacher will answer it for you, or I can help you out with that. If there's no further issues, I'm gonna be moving on. So here's a quick exercise. So what Pandas function do we want to use to create a data frame? How about you guys put that in general? Or yeah, if you can just type that in general, or just do it on your own computer. I'll give you guys a few seconds for that. Okay, so what do we use to create a data frame in Pandas? It's kind of self-explanatory. We just say data frame. And once again, what that does is it turns our data from a normal Python array to a fancy Pandas data frame. And if we click submit answer, you'll see it's correct. Alright, so that was a lot, I know, but I'm going to be moving on. So a little more about CSV files. We kind of already talked about this, but this is just introducing what CSV files are. So it's a simple way to store big data sets, and it's called CSV because the numbers or the data is separated by commas. That's how the computer knows what each separate data is. So they contain plain text and is a well-known format that can be read by everyone, including Pandas. So in our examples, we'll be using a CSV file called data.csv. Let me actually rename this just so we can be on the same page. I called it data.csv. And to rename files in Jupyter, just right-click, click rename. All right. So just to show you, right, if I do data.csv, works. Okay. So hopefully you guys will be able to rename. You don't have to rename your file, I was just doing it so it can be in sync with the curriculum. So now we already did this pd.readcsv, and then here's another function called toString. So if we do this, print df.toString. I mean, not much changed, but yeah, if you print df.toString, same thing. And oh, here it tells us what toString does is it prints the entire data frame. So yeah, if you have a really large data set, like, I don't know if this will work. Yeah, but let's say you had a large, like a really massive data set. If you just do print df like we did here, it won't print the entire thing. It'll print the first 5 rows and columns just to save space. But if you use a toString function, it'll print the entire thing. This is probably not the best example for that, but just trust me. Okay. And then another one is max rows. So this is a function in Pandas. And if we do pd.options.display max rows, this is the maximum number of rows defined in the Pandas option settings. So if I tried this myself, you'll see it print 60. So I guess that means that when you are printing a data set, the max amount of rows it'll give you is 60. So I'll give you guys a few seconds to code out what we just did. And once again, if I'm like going too fast or you need clarification on something, please ask in the class 1, 2, and 3 chats. Alright, with that said, I'm gonna be moving on now. Alright, so we can change the maximum number of rows if we want and manually override it using the pd .maxRows function again. So let's say we wanted to change it to 9,000. We can do pd.options.display.maxRows equal 9,000. If you run it, there's no output, but let's say I want to print it now just to check what it is. pd.options.display maxRows. You'll see now the maximum number of rows that we can print is 9,000. All right. Moving on. Now we're going to talk about Json files. So Json is another format for files, another way we can store big data sets. I don't know what Json stands for. If you have the interest or the time, you can search that up on your own. But it is plain text, but it has the format of an object. And JSON files are used all the time in programming, including Pandas. So we have a JSON file here. I don't know if there's a way to download this. I'm not sure if this will work, but let me just try it. No. You know what? Hold on, guys. Give me a few seconds to see if this will even work. Okay, it works. So I'm gonna send you guys this link in the chat. And let's. And what this is a big data set. And if you right click it, if you right click it like that, and then you click save link as, it should let you save it, and then you name it. I just called it data, just so it's easier. And then you do .json. Okay, that's very important. It will save the file as a JSON file. Okay. And then once you have that on your computer, you can put it in Jupyter the same way we did with the data.csv file. So on my computer, I can drag and drop. Otherwise, press this arrow up here, and then you can just find it in your downloads or wherever. So once you do that, just double press it and it will open up. And I'll give everyone a few minutes to work on that. If you have issues, feel free to ask questions in the chat. Okay. Unless there are any problems, which please let me know, I'm gonna move on. So let's take a look at this JSON file. It's not really related to Pandas, but still pretty good to look at. So we have our root, and then duration, pulse, max pulse calories. And that's just the way it was set up. So duration, if you notice, this is like a big data set. Actually, how about we load it first? So here's the code that we loaded. We do not need this import pandas as PD because we already have pandas available. And then we have df equals pd or pandas dot read JSON. Right? So before we had read CSV, now we have read JSON because it's a different type of file. And then in the parentheses as an argument, you just put in the name of the file. For me, it's called data.json, but just put in whatever you have in the quotes. And then we have print df.toString. And remember, the toString function just allows us to print the entire thing. And let's say I didn't have that. Or I changed the max, I guess, so. Interesting. Okay, so let's take a look at this. So we have our column names, duration, pulse, max pulse calories. If you look in our JSON file, these were the first or the outermost array index names, if that makes sense. So inside each one of these, then we have our data, and each data has an index 0, 1, 2, 3, 4, on, and that's what we have here. 0, 1, 2, 3, 4, on until 168. And then this is our data. And you'll notice it's nicely formatted in a Pandas data frame. So that is how we do a data as a JSON file in Pandas. Okay, I was just testing something right there. Alright, so I'll give you guys a few seconds to do that, and then we'll move on. Okay, so I'm assuming everything's working well. And then I'm going to talk a little bit more about JSON files. So JSON files or JSON objects are the same format as Python dictionaries, which hopefully you guys know. And let's say your data is in a Python dictionary and not a JSON file. You can just load it directly. We already did this many times before, just using the pd.dataframe function. This is just much bigger than what we had before. So, I mean, I don't think it's necessary for you guys to go ahead and copy all this, because it's just a bigger example. I can't even copy it. Just a bigger example of what we had before. But yeah, actually, let's go down real quick. So let's say instead of a JSON file, we had a Python dictionary, right? So we can say data equals to, and then this is our dictionary. And then we had, let's say, row 1. And then in row 1, we have call 1. And the data for call 1, row 1 is 1. And then I'm just going to do like maybe 2 or 3 columns for each one. And feel free to follow along with me while I'm coding this up, just so you don't have to, yeah, call 3, 3. Alright, so that was our first, sorry, this should be column 1. And these are row 1, row 2, row 3. Alright, so what I'm doing is this is just the same thing as a JSON file, but I'm just making it by hand just to show you it works, just to prove it. And then we have a second column, I'll say call 2. And then this again is its own dictionary. And let's say we have row 1 again, maybe 4. Row 2, 5. Then row 3, 6. I think that's enough for now. And then hopefully this works. Alright, so just explain what I did. I made a multi-dimensional array in Python, or Python dictionary. And the outermost dictionary is these two, call 1, call 2. And that's the key. And then the value for each one is its own dictionary with the keys row 1, row 2, row 3. And the values 1, 2, 3, 4, 5, 6. So you'll see that my outermost keys are my columns, and then my inner keys, row 1, row 2, row 3, are my row names, row indexes. And then we have our data here. Okay. And then just another note, I kind of got lazy. I just directly printed it after turning it into a data frame. But if you want, you can create a data frame object and then print the object. Same thing. So yeah, I'll give you guys a few minutes to finish up on that. After class, if you have time, you can try making it bigger, add more columns, more rows. You don't have to use numbers. You don't have to use rows, or the name row can be creative. I was just doing this, so we move on. All right, so I know I'm moving kind of fast. Let me know if you're still coding or if you have questions, something's not working, anything, please put it in class 1, class 2, class 3, because I do not want you to get left behind. With that said, moving on. So now we're going to talk about how we analyze data frames. So this is the most important part. What we just learned before is how to set up the data, just how to get it working in Pandas, and now we have to actually analyze it. So this is what I was trying to do earlier if you saw, but the head function, basically, let's say we're using this big one again, right? I forgot what I called it. Let's call it df. Let me get rid of all this. All right, so if I do print df, anyways, so we have df right here, and it's this massive data set, right? This was the one we downloaded online. It's a JSON file. And sometimes you don't want to just look at this massive thing. So what you can do is print df.head. And what that does, by default, it'll print the first 5 rows. Okay? And it's called head because it's like the top, right? Let's say you wanted the first 10, you can just put 10 in the parentheses, and it'll give you the first 10 rows. So yeah, that's the df.head function. Or not df, pandas head function, and df is just the name of the data set you're working with. Okay, so hopefully that works. And yeah, you'll see you can add a number to specify the number of rows you want. And if you don't specify a number, then it'll just give you the first 5 rows. 0, 1, 2, 3, 4. And then just like how we can print the top with head, we can print the bottom with tails. Tail, sorry. And tail is the last 5 rows. And once again, you can specify how many, last 10 rows. Just remember heads top, tail bottom, right? Pretty simple. Okay, and then this is a function called info, short for information. And it just gives you some basic info about the data set. Let's say your friend gives you a data set and you're like, what is this, right? So if you do print df.info, it'll tell you it's a pandas data frame. That's what this object is. That's what df is. Okay. It's an int 64, so that's the type of data. And 169 entries, 0 to 168. So the first entry or the first index is called 0. Right? It's these numbers right here. The last one is called 168, and there's 169 of them. And then there's 4 columns, and they tell us the names right here: duration, pulse, max pulse, calorie, right here. And then if you notice that the type for calories is actually a float, so it'll tell you that right here. And then the non-null count is, so oftentimes when you're working with data in the real world, it's not going to be perfect like this. When you're collecting data, some of it might be empty, you'll have missing data, and that's what we call null. Right, so it will tell you how many is non-null, or how many of these items in the series, remember each one of these columns is called a series, is actually filled. So that's pretty useful, and it'll tell you the number of types. We have 1 series of floats and then 3 series of ints, and the memory usage, which is pretty useful. So yeah, that's pandas.info, pretty useful. And this was just explaining what it was. And these were talking about what the null value stuff is. And oh yeah, I guess there were 5 null values in the calories thing. So if we want to find that, you go to calories, you'll see we have a few null here. Okay. Okay. Moving on. Cleaning data. So this is also another important aspect of data science, machine learning, whatever you choose to do with pandas. Data is rarely perfect, and you're gonna need to fix it before you can use it for whatever you do. So bad data could be empty cells, like the null data, like we talked about, data in the wrong format. Let's say you wanted like things in inches and they give it to you in centimeters, right? Or simply wrong data or duplicates. And we're going to learn how to deal with all of these coming up. So this is our example data set. I don't know if they'll give it to us. Maybe, yeah, hold on, let me see if I can. Yeah. I don't know why they gave us a data set that we can't even use. But move on. So empty cells. Alright, so let's say yeah, let me see if there's a way I can get this into Sheets so you guys can use this, because I really do want you guys to see this example, because it's not the same just looking at it. Jeez. Okay, yeah, sorry about that. I guess we can't follow along, but we can learn the functions. So our first one is, how do we remove rows? So oftentimes we'll have rows that are just straight empty, and we can do that. We can remove those rows with the drop NA function. And what the drop NA function does is it returns a new data frame, so a copy of the original one that you're using. And oh, that's pretty good. So we do have the data sets actually. I don't know if I could copy this link. Yeah. Here's the data set. So once you have that, open it, save it to your computer, and put it in Jupyter. It's called dirtydata.csv. So comma separated values file. We talked about that before. I'll give everyone a few seconds to load that in. If you open it, it'll look something like this. And if you're wondering how to do that, just click the link I sent you. And then File, save. Yeah, just save as data.nottext CSV. Or when you right click the link, just do save link as. So I'm assuming that everyone got this in their Jupyter notebook, hopefully. And then we can just load the data using data equals pt.load CSV dirty data.csv. Oh, sorry, it was read CSV, not load CSV. Make sure you have these in input. Alright, so now we have our data in Python. And this is still not a pandas data frame, so we can do that by doing df equals pd.dataframe data. Right, and if you want to just take a look at it, you can say print df.head. Right, these are the first 10 or first 5 rows. Give y'all a few seconds to do that, and then we'll start working with our data. Okay. Last roll call, if anyone is not able to get this and wants help, please say something in chat, because otherwise I will not know. Alright, so our first function is the drop NA function. And let's just test it out first. We can say new df equals pd.drop NA df. And what did I do wrong? Oh, it's df.drop NA. So that ran. And then if we take a look at our data set now, let's see if we can find any differences between them. So you'll see in line 22, we had a null value in the date. If you look at line 22, it just straight up deleted the entire line. Right. So new df and df are two different things now. It made a copy of df and then changed it. So it didn't directly change df. That makes sense. What else? 18 had a null value here. The NaN means null. And then if you see, it just deleted 18 also. And the last one, I believe, should have been 28. And 20 also had a null value. So that's what drop NA means. It'll just delete any rows that have null values. And then, yeah, if you want to directly change the data frame, you don't want to make a copy, you can just say in place equals true. And I'll start that. Drop NA in place equals true. And yeah. Yeah, so now you'll see that df is actually the one that was changed. Alright, so moving on, this was just what we did, drop NA. And what we can also do is fill NA. So before we do that, let me delete these lines just so we can get df back as normal, just to make sure. Yep. So now we have our data with our missing values, right? And just delete the stuff we did before because we don't want to actually change the data frame in place because we're still going to be using it. So you can just delete all that. So now we have df as this data frame that is not perfect. We have missing values. Let's say we wanted to just fill those values in with something instead of deleting them. So that's where the fill na function comes in. And what it does is it replaces null values with whatever you want. So in this case, we'll do df.fillNA 130. And I'm not going to change it in place because that's just extra work. New df equals df.fillNA 130. If we print new df, you'll see that the places where it was null, or man, now have changed to 130. Right. And then once again, you can do the in place equals true if you want to directly change it. Alright, so moving on, unless anyone has questions about this. Okay. So now, let's say you don't want to change or replace stuff for the entire data frame. You only want to do it for specified columns. It's just the same thing as before, but after df, let's say you only want to change stuff in calories, because if you have a date that's like 130, that doesn't make sense, right? So let's say you want the default calories to be 130, and say df calories fill na, and let's see what I did wrong. Oh, calories is capitalized. Okay, so now if you print new df, then you'll see here is our df's calories, right? We had nan here in row 18, and then now it's just 130. Let's do in place equals true. So taking a look at the entire data frame, what I just did was I directly modified it like we talked about before, using in place equals true, just so we can see the entire data frame. So you'll see we still have no values in the date. We have no values in, we didn't have any before, but in calories, right? This one used to be null, and we have 130 now. And then 28 used to be null, and that's 130. Okay. That is how you specify. Just another example, let's say we only wanted to change the date. Then let's say our default date is, I'll say like 2022 06/14 over here. And if we print it, then you'll see we had a missing date in 22. And now we have 2022 06/14. And you'll see we still have 130 here because we changed it in place already. But if I reload this, okay. Yeah, so that was the fill NA, and just a recap on what it does, it fills all null values with whatever you want here. And then you can specify a value of what you want to put. And then another thing you can do is, here, let me delete this real quick just so we can have a fresh data frame once again. Oops. Alright, so we got our no values again. And what I did, I just deleted all the stuff we just did, just so we can go back to the dirty data. Let's see. So let's say you want to replace the null with a mean value, because that's just a good starting point. So what you can do is use the mean, median, and mode functions. Hopefully you guys know what that is, but if you don't, mean just means add everything up, divide by the number of items. Median is the middle item when you're going, when you sort it. And mode is just the item that appears the most. And then what we can do is, let's say we want to find the mean calorie, average calorie. So we can say average cal equals df as our data frame calories dot mean print average calories. And then you'll see, so our average number of calories in these 31 days is 304.68. So now we have this average calories value. If you wanted to make all the null values average calories, then what you can do is df.fillNA, right? That was what we learned before. And we only want to do the calories column. .fillNA with average calories. And then once again, if you want to see the whole data frame, you have to do in place equals true, print df. So now you'll see, once again, we didn't change any of the null values in any column except calories. And these null values are all 304.6, which is our mean value. So if I comment this out, and then I load my data set again. Alright. And then we can do the same thing with median. So you'll see the median is 291.2. And then if I comment this back out and I run it, you'll see it puts 291.2 as the filler for null values. So if you notice, we haven't really done anything new in terms of functions, right? With the fill NA, all we did was just specify a different number. And then you could probably guess the same thing would happen if you use mode. It would just find which one of these numbers appears the most, set that equal to average cal, and then when you fill with average cal, it will use that number. So give you guys a few seconds to do that. Here's the code for the mean. Okay. Alright, moving on. This is just mean, median, and mode. So now we have, that was cleaning data that is null, and here's how we clean data of the wrong format. So if we look at rows 22 and 26, alright, so this one is just null, so that's wrong. Like we're looking at the dates, right? So the dates are formatted by year slash, I'm guessing, yes, slash month slash day. And this one's null, so that's wrong. And this one, they forgot the slashes. So here's how we can convert the cells in the date column into dates. So Pandas actually has this really useful function called toDateTime. And what it does is it just converts, like before it was 2020, 12, 26, and it'll just take that and convert it into the right format. So that's actually really useful. Let's copy paste this code. Alright, so what this does, it looks only at the date column, right? And then it'll change it to the right format using toDateTime. And then once again, we're only looking at the date column. This should allow us to print the whole thing. Alright, so if we look at line 26, this was the one that was in the wrong format before. And we'll see it's in the correct format now. So, yeah, let you guys try that. Okay, moving on. Yep, it's just explaining what this function does, and yeah, like we said, it doesn't change null value, but it will change it to NAT, which stands for not a time. And then once again, we know the drop NA method. I'll just delete all the rows that have a null value. And NAT is considered a null value. So if we do df.drop NA subset equals date, and the subset, all that means is we're looking at the date column. And then we're going to change it in place again. And we get an error. Date is capitalized. You'll see we dropped line, what was it, 22, right? So you just straight up deleted the whole line because it had a null value. So we already knew that though, just proving that it works. Alright, give you guys a few seconds to code this out. We already did this before, but just so we can reiterate, drop NA deletes rows that have any type of null value, but in this case we are only looking at the subset in date. And we are changing the data frame in place, so we're directly changing df. We're not making a copy or anything. Alright, I'm going to be moving on. We have a little bit of time left. Let's keep chugging along. Fixing wrong data. Okay, so this is just straight up wrong. Like someone registered 199 instead of 1.99 or something. Like for example, we have duration of 450, and you can see that just doesn't match the other numbers. I'm guessing that this is the time of people's workouts. Yeah, and most people wouldn't work out for 450 minutes straight. I'm guessing they meant to write 45. But yeah, that's life. Sometimes you just get bad data. Okay, so how do we fix this? Well, we can replace values, right? So, I mean, this is just straight up replacing it. So let's say you're looking at it and you're like, oh, that's obviously not right. So what we can do is we use the loc function again. So df.loc, short for locate, right? And what row is that? Row 7. And first argument is the row. We have our column. And the column is called duration, capitalized. And then now we can just set it to whatever we want. So I'll set it to 45. And then print df. You'll see now it's 45. So kind of like arrays in Python, how we would change them, but instead of doing like that, right, you just use a comma. So yeah, that's how we access values in our 2D data frames. Row first, then column. So yeah, like I said here, this works for small data sets when you see problems one by one, but not for big data sets. So this next example is going through how we can create our own rules or set some boundaries for our values. So I don't know if we learned loops, but if you know what loops are, so we're going through every value or every row in our df. Right, so for x in df.index, and that's basically saying for every index in our data frame. So in this case, it'll be 0, 1, 2, 3, 4, 5, 6, 7, 8, on and on, right? For each one, if we locate the index x in the duration column, if it's more than 120, then we'll just set it to 120. So we're basically setting a cap on the values. Right, so I already changed this in place, but I'll say for x in df.index is, right? Yeah, index. So this is looking at every index. If pd.locate or df.locate, sorry. Locate. So what row are we looking at? Well, we're looking at row x, right? And what column? Duration. Or let's say I'll do it with pulse. Alright, so let's say, and actually that's not a good example. Let's do duration, right? So duration, you guys can play around with this, do whatever you want. But so for every item in the duration, that's basically what this is doing. If df.loc, if df.loc x duration, let's say if it's more than 50, right? We want to set the cap to 50, then we'll just set it equal to 50. If it's more than 50, then we set it equal to 50. Now we can just print df. And then you'll see for every one that was more than 50, it got set to 50. So this is not really a specific function. It's just kind of using some logic and some if statements. I think that will be the last thing we learn because, yeah, for today. So feel free to just not copy, but write down this code on your own. And you don't have to use the duration column. You can try with pulse. Let's say I do the pulse and I want to set the max pulse equal to 50. Then basically all of them get set to 50. Maybe I'll do 100. So, oh yeah, I already changed it, so that doesn't work. But yeah. So We learned the loc function. We learned how to delete null values using drop NA. We learned how to fill null values using fill NA. We have to datetime. And yeah, we learned quite a bit today. And feel free to ask any questions in the chat if you don't get anything.
Yeah, okay, so I think we're pretty much done, right? So if you guys had any questions, like Andy said, we learned a lot. So feel free to always ask in your class channels. And today's homework will be doing the certificates for the other Python courses.